Hello and welcome on board the International Space Station ISS. My name is Thomas Reiter. I am an astronaut of the European Space Agency ESA. In 2006 I spent 170 days on the ISS. This mission was called Astrolab. I would like to take you on a guided tour through the station and explain you our life and work on board. Please put on your red and blue glasses for the stereoscopic photos that I will show to you. We start our tour in the Russian habitation and laboratory module Zvezda. Here you see the cockpit or the bridge of the station. It does definitely not look like a spaceship Enterprise. From here we can remotely control the incoming Russian Progress spacecraft. The instruments will also allow us to monitor the rendezvous and docking of the European Automated Transfer Vehicle ATV. Now let's turn around and look at the living area of Zvezda. You see the open door to one of the two sleeping cabins and you see our dining table. Here you see my cosmonaut colleagues Pavel Vinogradov and Mikhail Turin preparing dinner, together with the first female spaceflight participant Anusha Ansari. We use this table for eating. We extend it over the whole width of Zvezda. Without the extension, we also use the table as a working desk. Here you can see me preparing ESA's new 3D video camera, the ERB, which I use to make stereoscopic film shootings. On the left side, you can see my open sleeping cabin. Not far behind the table is the toilet. You can just see a part of the seat. It is only separated from the rest of the cabin by this simple orange curtain. Let us now move further to the rear end of Zvezda. You see the docking port which allows for the docking of the Russian Soyuz and Progress spacecraft and in the future also of the European Automated Transfer Vehicle. When I took this photo, the manned Soyuz TMR-9 was docked there, which had brought the new crew up on 20th September 2006, with whom I then stayed on the station until December 2006 as the Expedition 14 crew. Now we turn around and look back to the dining table, with some food attached by Velcro to the walls. We float to the other end of Zvezda and then through the transfer tunnel into the next module. Here we are in Pirs. This is one of the Russian elements of the ISS. It has a docking port for Soyuz and Progress spacecraft. It also has an airlock. Through the airlock, the astronauts can leave the cabin to work outside the station. Here you see one of the Russian Orlan spacesuits, which are worn during these extravehicular activities. I was dressed in a similar spacesuit when I was working outside the Russian Mir station in 1995. However, this time during the Astrolab mission, when I was working outside the ISS on 4th of August 2006, I used an American spacesuit, which I will show you later. We leave Pirs and float into Zarya. Zarya was the first element of the space station that was launched into orbit. It is mainly used for the generation of electric energy and for storage. Here you see batteries and other spare parts. As you can see, Zarya also holds clothes and shoes and the food reserves of the station. These are the boxes on the floor in front of us. Let's turn around behind the shoes and float into the opposite direction. You see more astronaut food and you see on the left wall our washing room. You might notice the towel on the wall and the mirror behind and the other personal hygiene objects around the mirror. That is all what we have to wash ourselves and brush our teeth. There is no shower or even a hand basin. Now we leave Zarya, which we also call the FGB, and float into the next module. On our way out, we float over a lot of stored luggage. Here we are now on US grounds in the Unity module. which is also known as Node 1. Did you think that astronauts have no sense of humor? That is not true. Look at the traffic signs, which say that there is a space station under construction and that the speed is limited to 17,500 miles or 28,000 kilometers per hour. As one tour around the Earth makes up for 40,000 kilometers, this cosmic speed brings us once around the whole Earth in just 1.5 hours. In Unity, there is our telephone booth and internet cafe. In fact, there are laptops on the left wall which we can use for our private email and telephone calls via satellite. We can directly call any telephone number on Earth. Now we look into the opposite direction towards the American laboratory Destiny. Unity is quite spacious. Here you see my American colleague Jeff Williams floating. You will notice his fashionable beach shirt. Unfortunately, there is no way to go to the beach from here. On a sign it says 2AL. That is not a wrong spelling for Los Angeles, but the abbreviation for the word airlock. The American airlock module is called Quest, and we will now float into Quest. Quest has 2 compartments. In the first compartment, it holds 2 American spacesuits. The helmets are protected by a cover and the gloves are stored separately. Looks as if the empty spacesuit wanted to say to us, "No pictures please." Behind you see the second chamber. That is the airlock through which we can leave the station and work outside. This is the spacesuit that I was wearing when I performed an extravehicular activity in August 2006. There is a German flag on the left arm. As you might have already noticed from my accent, I'm a German. I was born in Frankfurt. Here you can see my own mirror image on the helmet. When we are working outside the station, we are always doing that in pairs. I work together with Jeff Williams from NASA, who is on the right behind his suit. In the middle is our commander Pavel Vinogradov from Russia, who guarded the station while we were out, and he supported our work from inside. Together, the 3 of us formed the Expedition 13 crew. My ESA astronaut colleague from Sweden, Krista Fuglesang, joined me on the space station in December 2006 for the Celsius mission, and he also performed extravehicular activities. Journalists often call that a spacewalk, but it is all but a walk in the park. It is really hard work, both physically and mentally. Krista went out 3 times during his stay on the station to mount equipment and fix a problem with a pair of solar panels which did not want to retract automatically. Let's leave the spacesuits and float into the last module that I wanted to show to you, the American Laboratory Destiny. As you can observe, there is a lot to see here. Let's start with the ceiling. This is the European deep freezer Melfi, which I helped to install and put into operations. It's used to store biological samples at temperatures going as low as -95 degrees Celsius. We also use it to freeze samples of our own blood and saliva for later analysis by scientists on Earth. Behind Melfi is another facility built by ESA that is used for life science research. It is called the EMCS, the European Modular Cultivation System. It is a kind of greenhouse in space. Below you see an ergometer called CIVIS. And here you see again ESA's new stereoscopic video camera called ERB, which are used for taking images of the station. This shall allow the ESA Erasmus Center to produce more detailed and up-to-date virtual reality modules of the interior of the station. It can help the mission controllers and support engineers on the ground to know what is where on the station and scientists to better design new experiments and their integration into the existing environment. Above the camera you can see again the EMCS and Melfi. Here we have a closer look on NASA's Civis ergometer. That is one of the training devices which I used every day for keeping my physical fitness. At the end of the Destiny laboratory there is a hatch. When this hatch is closed, the commander uses this area as a closet for clothes, but when it is open, it means that there is a space shuttle docked behind. Let's float through the transfer tunnel into the shuttle and have a quick look into the cockpit. That's me sitting in the pilot's seat. I was a fighter pilot with the German Air Force before joining ESA, and you can thus imagine that I would have loved to pilot the shuttle. But I was also very happy and proud to be a passenger. Time for us to leave the shuttle's cockpit, since I still want to show you other interesting things in the Destiny laboratory. Here you see on the left wall yet another European-built research facility, the Microgravity Science Glove Box. A little bit further away, also on the left side, we come to the control post for the Canadian robotic arm. You see that behind every intelligent and agile space robot, there is always an even more intelligent and agile astronaut. One of the nicest features in Destiny is the window. All astronauts spend a lot of their free time to look out of the various windows of the station. Here we see some of the solar panels that supply electric energy to the station and the radiators which cool the station. It is so nice to observe the play of light and shadow on the panels. This photo shows the Soyuz TMA-8 spacecraft, with which my crew colleagues Pavlino Gradov and Jeff Williams had arrived to the station. You also see the Canadian robotic arm as it's stretched out and an empty docking port for the space shuttle. The Earth always offers most beautiful views. Look how thin and fragile is the atmosphere. The clouds are clearly visible from an altitude of 350 kilometers at which the station flies. It is often difficult to say whether we are flying over land or over sea, and over clouds or over ice and snow, like what we see here below us. Did I say below? In fact, that depends totally on our own viewpoint. If you turn the head, then the Earth is hanging on your side or even floating above you. It is particularly pleasant to look out of the window, especially when you are expecting friends to visit you. Here we see Space Shuttle Discovery approaching in December 2006. On board arrived my ESA astronaut colleague Christer Fuglesang from Sweden. Together with him we returned to Earth 11 days later. There is one thing that is even nicer than looking out of the window, and that is working outside the station. This is the central framework structure of the station called the truss. Both Christer Fuglesang and I worked in this area, me in August 2006 and he 3 times in December. I installed some experiment equipment there and I prepared the station for the arrival of new solar panels and laboratories, including in particular the European Columbus Laboratory. The truss is not just a simple pillar. It is fully packed with equipment for energy supply, cooling and telecommunication. It also carries the large Canadian robotic arm, which is used to support us when we are working outside. This completes our tour around the International Space Station. I hope that the stereoscopic images and my explanations could help you to get a better understanding of how the station looks like and under which conditions we live and work there. Maybe you see now the station with a new eye the next time you watch it flying over you in the night sky. All the best to you and goodbye.